Hi, in this video we are going to discuss about the types of proximity sensors and the Hall effect sensor. That Hall effect, first one is transducer sensor topics we are seeing in this sensor. A proximity sensor is a one which is used to detect an object without touching that object. So wherever the applications are needed in most of the automotive system, automated guided vehicles or parking sensor of a vehicle, lift mechanism. When you go for a lift, that is opening and closing doors, and in a big industries or very big malls and all, we can see that doors are getting open and closed when an object is coming nearby. That also we can, that is without touching the door, it can operate. How it is possible is with the help of detecting the object coming nearby, so it will give an output signal to the system. So from that it helps. So the application, there are so many applications are there. Let me see this. One is the type how it is functions are inductive, capacitive, ultrasonic and optical. So inductive capacity is already we have discussed that it emits an electromotive force or electrical magnetic field here. So that when another component come near to the job, then automatically it cuts off. There is a change in the oscillation frequency. So when there is a frequency of waves it's passed on, when another component or a metal component coming nearby, there is a change in the oscillator frequency, so that it gives a return signal to that there is some object is over. That is inductive proximity. Capacitive proximity is a one plate of capacitor. That's what we know, cathode and anode, like two plates. So it's a charge, it will be used for the charging that. And normally one plate will be in the system, another plate in the metal object or non-metal object, whatever it may be. When they come to closer, then this the gap between the two objects, when it gets nearer and nearer, it allows the flow of current to in between these two plates. So that time we come to know the return signal. So there is a change in the current sensor and it will get the output. Then it gives the return signal. This is one type which is called capacitive proximity. And the third one is the ultrasonic proximity sensor, where a signal, ultrasonic wave signal, is sent by the transmitter and it is getting received by the transmitter. One more two ultrasonic sensors will be there. One is a transmitter, another one is receiver. So it depends upon the timing, how long it will take to return, is it says the distance between the object. So these three already we have seen in the last videos. And now is the optical proximity sensor. So optical proximity sensor is a with the help of light source. So it detects the light. Okay, so a sensor commonly known as a light beam sensor or through beam type and retro reflective type. Two types of optical proximity sensor are there. So when the light falls on the sensor, normally we are using infrared rays. This is what that we have studied in photovoltaic emission is somewhat different. When light falls on that, it will detect. Okay, that is different. Here, a light sensor, with the help of light, what it will do is we will send some lights through the sensor. It will hit and return back, just like what we see in the ultrasonic waves. So every light sensor used photoconductive material that become the better conductors. So it allows the current to pass when the light energy is struck on them, right? Let me see here in the next the optical proximity retro reflective sensor. Just like ultrasonic sensors, here also one transmitter and one receiver will be there, and both are located in the same system, in the same sensor. Okay, so sensor one phase it will be there. That's what we can say. Retro reflective light sensors have a transmitter and a receiver in the same package. So that what will happen is it will detect the targets when the rays get reflected back. So the main aim is to get return back of the ultrasonic infrared light. Why we use infrared light is it's unique and the wavelengths are and moreover in this case we have to make assure that uh, the waves whatever it is getting received, that light waves whatever we are getting received should be matched with the frequency what we are emitting. So the emitting and receiving the light source are very important. If another waves comes with another frequency, another light wave comes, it should not get attracted. So that is the thing we have to focus in this way. Another one is this through beam. Here emitters are one side and detectors are another side, so that the light is passing through that, and detectors on the opposite side receiving the signals of the light. And if any obstacles getting in between these two emitters and detectors, then the flow of the movement of the light from the emitter to detector, it gets cut off, so that there is a input signal or return signal goes there. There is an obstacle is moving inside, like. So you can see this is through beam proximity sensor, where one sensor is out, there is the opposite of this light sensor, where transmitter and this emit receiver will be directly opposite to that. There is no receiver of ecosystem, but in this case the pulse generator, it produces this pulse, and it goes that light transmitter. Through the light transmitter, the light is passing, the infrared light passes, and one light sensor, that is a receiver, it will receive the light source which is transmitted on the opposite side. So when the light rays passes in between these two sensor, and now if we move any obstacles inside, so let it be a washing machine control system or wash basin control system. So when we are inserting our hands, or like for washing, suddenly there is a change in this flow of the light. It obstructs that way of light, so that there is a signal goes to the current sensor. There is a change in the current movement. So immediately it will make the motor, it will give signal to the another motor to switch on for supply of the fluid or something else. Like that it will be there in case of in industries, emergency switch off in automation machine. If somebody brings their hand in between the working machine, it will identify that some object is coming near to the rotating element. So it detects immediately, and it sends signal to the output device and microcontroller based operating. And this is used for the controlling. Just sensor is just to detect the whether the any components is coming near or not. That is the only thing the sensor can do. By using these outputs, another application, so it will be used for door opening, closing, or emergency switching off, like that it will happen. So this is the one type. And hall effective sensors are there when flow of electrons is the flow of current is getting distracted with a magnetic field. Okay, when a perpendicular magnetic field, magnetic bar or north south bar, when it comes near to the flow of charges, suddenly the side plates, the conductor plates are getting charged, so that the electrons are getting the charged particles getting diverted from their track. So by this way we come to know that is some obstacle objectives are getting nearer. Okay, so this is the way one. This is also a sensor, proximity sensor. Without touching that, we come to know that object is nearing. So here in the deflection of charged particle from their regular path due to the influence of magnetic field is called Hall effect. So this sensor is called Hall effect sensor. The flow of charged particles deflection changes place due to the influence of magnetic field. So it is a potential difference created on the opposite side of the electrical conductor through which the current is passed. So in this image we come to know that, so the electrical conductor is a plate where the electrical charges are moving in a particular path. But suddenly when a magnet, another product which is having a magnetism sensor magnet which is comes near to this job, the change in the current flow, and the sides of the conductor gets magnetized, so that the charged particles get deflected. So this also it's a help for finding any objects coming nearby. So all the sensors and transducers we have seen, due to the magnetic force in the Hall effective sensor, that's what the thing, it is during the magnetic force are pushed sidewards towards the edges of the slab, so that electrical field is created and charge gets accumulated in the side. Okay. These videos we have seen, these are all the types of sensors and transducers. Okay, thank you.